Welcome to all. So let us start with the next topic. Okay, in the previous video we have seen how to interpret decimal number systems. If you want to see, you can recall those concepts. So this was the example I have given in the previous video. So you can see how to represent 2025 in a actual way, like how system interpret your number. Based on that, I have given that particular example. So you can see in the next second line, you can see the polynomial representation, isn't it? You are taking a number and you are multiplying that number with the base value. So decimal will have the base value 10, isn't it? So I have just created that polynomial based on the base value. In the same fashion, you can see in this example, you can see, let me zoom in a little bit. So decimal number system has the base value 10. So base or radix, so you can use both the terminologies. Any terminology is fine. You can use base or radix, radix. Okay, so whenever I say base 10, what is the meaning? So base 10 is nothing but the number ranges from 0 to 9. What is this 0 to 9? So these are the numbers which you are using for your polynomial, isn't it? Any number into 10 to the power 0, any number into 10 to the power 1. So up to 10 to the power 9 you can represent in decimal number system, isn't it? So what will be the actual number? If you represent 10 to the power 9, it will be a very big number, isn't it? 10 into 10 into 10 into and so on. So you have to multiply 10 total 9 times. It is not 10 into 9. No, not like that. 10 into 10 into 10 into 10. Like that, you have to multiply 10 9 times. So you will get a big number, very big number, isn't it? That is the meaning. So in the decimal number system, the base value is 10. So the number ranges from 0 to 9. That directly means you can use the polynomial up to 10 to the power 9. Okay, then the second number system is binary number system. Binary number system is nothing but either 0 or 1. So that is the reason why we say it has got base 2. And remember one thing, in the previous video while explaining about the computer system, I said in computer everything is numbers, isn't it? So ultimately, if you want to use signal, as a computer is an electronic device, if you want to use signals, definitely you require 0 or 1. It is nothing but power off or power on, or you are supplying current, or if you are not, you are not supplying current. So it has got some value, isn't it? See, if you are supplying current, then it may be 1. If you are not supplying current, it may be 0. Isn't it? So it can interpret like that. So binary system is nothing but 0 or 1. So in your system, whatever it may be the number, whatever it may be the graphical representation, whatever it may be the file, ultimately in your memory you are going to store zeros or ones. Okay, you have to remember that entire computer system runs under binary system, binary number system. Okay, ultimately everything will be 0 or 1. So it is your work to convert, or it is your work to understand how exactly you can convert the different type of number system to binary number system, because your computer understand only binary values, isn't it? That is the reason why binary system has given a base 2. Okay, the next number system is octal number system, which has got radix or base 8. So base 8 is nothing but the number ranges from 0 to 7. What is the meaning 0 to 7? In the sense, if you give any number in octal number system, you have to write the polynomial in in a fashion like any number into 8 to the power 0, or say for example you are taking 23. And if you want to represent 23 in decimal form, say for example 23 is in octal number system, then how to convert that, or how to represent, or how to interpret that 23? It is nothing but 2 into 8 to the power 1 plus 3 into 8 to the power 0. So in which fashion you have done in the decimal number system, the same fashion you have to follow in your octal number system as well. But instead of giving base 10, here you are giving base 8. That is the difference. So in your next slides I am going to give the example as well, but as of now think octal number system where the number ranges from, or the radix or the polynomial values will ranges from 0 to 7. Okay, the next, last but not the least, the number system is hexadecimal number system, which has got the base 16. So the number ranges from 0 to 15. Okay, so you can see here in hexadecimal number system you can observe it is little bit change. It is little bit different from rest of the number system, isn't it? See, I have marked 10 as A, I have marked 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F. So from 0 to 9 it is same. You do not have any difference. So it is something like decimal number system itself. But after 9 you have A, B, C, D, E, F, total those 5 alphabets you are going to represent. 6 alphabet you are going to represent, isn't it? What is that? It is nothing but whenever you are using hexadecimal number system, you have to remember after 9, that is nothing but 10, 11, 12, 13, 14 and 15. So you have to represent those numbers in alphabetical way or alphabetical manner. So it has to be in capital letter itself. You have to use super case. You should not use lower case. Okay, uppercase has to be used. So it is nothing but A, B, C, D, E and F. It is by default understood that the hexadecimal number system ranges from 0 to F. That is nothing but 0 to 15. So whenever you are using hexadecimal number system, after 9 you should not say 10 or 11. You should be saying A or B or C and so on up to F. Why it is up to F? Because you are using base 16, isn't it? So base 16 is nothing but the number ranges from 0 to 15. So up to F or up to 15 you can represent in hexadecimal number system. Okay. The next example is, see, binary number system. We can understand this particular binary number system by taking this particular example. So it is nothing but if you want to represent any number in zeros and ones, how can you represent? Isn't it? You have to think. So while giving the explanation, I said everything is zeros and ones in computer system. But if the number is like 50 or if the number is like 80, so for example, you want to store some values like, say for example 123. How you are going to store 123 in computer system? Obviously you have to convert that number to zeros and ones. Now how can you convert that number to zeros and ones? You can convert that number, or you can convert any number to zeros and ones by using this particular fashion, whatever the fashion you are seeing in your screen. So it is better to start from right hand side. Always remember, whenever you are dealing with all zeros and ones, and whenever you are dealing with this octal or hexadecimal or the number systems, you have to think that you have to start from right hand side. This is applicable only if you do not have any decimal points. See, if you have decimal points, after the decimal points you have to start from left hand side. If you do not have any decimal points, then you have to consider the number from right hand side. That was the example I have given in the previous video while solving that, while interpreting that decimal value in hexadecimal number system. You can recall that example. Okay. Here, see, you can see in the next line, see in the first line you can see 2 to the power 0 and 2 to the power 1, 2 to the power 2, 2 to the power 3 up to 2 to the power 7. Okay, I represented, I just have written from right hand side to left hand side. Okay, now what is the value of 2 to the power 0? It is 1. Any number to the power 0 is 1. Now what is the value of 2 to the power 1? So any number to the power 1 is the same number. It is nothing but 2. What is 2 to the power 2? 2 to the power 2 is 4. How you got 4? 2 into 2. It is nothing but 4. What is 2 to the power 3? How you are going to get 8? 2 into 2 into 2. So if you do that, you are going to get the value 8. In the same fashion, if you want to get 2 to the power 7, so you have to multiply 2 7 times. 2 into 2 into 2 into so on. So you are going to get 128. So how many numbers you can form using these? You can form so many numbers. You can convert so many numbers into zeros and ones by taking this much example. You can go you can move further, like 2 to the power 8 also, 2 to the power 9 also. You can do that. But as of now, most of the numbers lies within this. If you are taking some simple examples, like the up to 150 or up to 200. So if you are taking like 12, 13, or if you are taking like 48, 57, such numbers, if you are taking, if you want to convert those number to binary, you can take this kind of examples. How you are going to convert, I am going to explain in the coming concepts. So you can come down, you can see there decimal and binary. I have just given one example over there. So decimal is nothing but the normal numbers, whatever the numbers you are using in your day-to-day life, isn't it? So numbers, I have listed 4 numbers over there: 0, 1, 2 and 3. Those numbers are normal numbers in your day-to-day life. In usually whatever the number system you follow, the same number I have written over there: 0, 1, 2, 3. Okay, in the right hand side, you can see below the binary heading, you can see 0 is represented as 0 0. Why it is like that? Why you are representing 0 as 0 0? Because this number system, see, I have taken total 4 numbers: 1 2 3 4. Now this 1 2 3 4, sorry, 0 1 2 3. So 0 1 2 3 has to be converted to binary. Okay, how you are going to convert that binary, those number to binary? By taking this particular example. You can concentrate on right hand side. See, I have in a small characters, I have written just 2 to the power 0 and 2 to the power 1. Okay, now whenever you are representing the number 0, you have to put 0 for both the numbers. You should not give any numbers. Okay, you should not put 1 over there. Why? Because 0 into 2 to the power 0 is 0. 0 into 2 to the power 1 is again 0. So ultimately you are going to get 0 itself. Okay, now come to decimal number 1. Okay, how to represent 1 in binary? You have to represent 1 in binary something like 1 into 2 to the power 0 plus 0 into 2 to the power 1. Fine. What is 1 into 2 to the power 0? 1 into 1. It is nothing but 1. 0 into 2 to the power 1. What is it? 0. Isn't it? Any number by, any number multiplied with 0 is 0. Now, how to represent decimal number 2 in binary? How you are going to do that? You are going to represent 2 by putting 1 below your 2 to the power 1. Why it is like that? You can see the above example. See, 2 to the power 1 is 2. 2 to the power 0 is 1. So, if you want to represent decimal number 2 in binary, you have to put 2. You have to put 1 below the actual number. That is nothing but 2. And you do not need to write anything in below the 2 to the power 0, because you don't need 1, isn't it? You just want to represent 2, number 2. So number 2 can be represented as 1 0. Okay, now how to represent decimal number 3? The 3 can be represented as 1 1. Why it is 1 1? 2 to the power 0 into 1 and 1 into 2 to the power 1. So how much you are going to get? 1 into 2 to the power 1 is nothing but 2, plus 1 into 2 to the power 0 is 1. 2 plus 1 is 3. So total you are going to get the decimal number 3. So 3 can be converted as 1 1 in binary. Okay, so you are going to get the better idea in your further examples. I will give so many examples for this, because when you are starting this concept from the scratch, it is better to understand in depth, because this kind of examples are required in your future days also, because computer only understands binary system. That is the reason why you have to understand this concept very well. Okay. The next example, see, representation from 0 to 7. How to represent the decimal number 0 to 7? Now you can observe one thing. See, in the previous example, yeah, I have taken only 4 numbers 0, 1, 2, 3. So I represented 0, 1, 2, 3 with only 2 bits. Okay, what you mean by bits? Bits are nothing but either 0 or 1. Bit is nothing but one position or one value. Okay, now do you remember, do you know about that bits, bytes, kilobytes concepts? If you don't know, see, bit is nothing but either 0 or 1. Byte is nothing but 8 bits. 1 byte equal to 8 bits. That means you have to have either 0 or 1, total 8. 8 position has to be filled. 1 byte equal to 8 bits. And 1 kilobyte is nothing but 1024 bytes. Okay, so 1 byte equal to 8 bits, and 1 kilobyte, 1 KB, 1 kilobyte is nothing but 1024 bytes. Okay, now 1 megabyte, what is 1 megabyte? 1 megabyte is nothing but 1024 kilobytes. 1024 kilobytes. Now what is 1 GB, 1 gigabyte? It is nothing but 1024 megabytes. Okay, like this. So all these bytes concept come into picture when you deal with zeros and ones. Okay, so in here to represent 0, 1, 2, 3, I have taken only 2 bits or 2 positions. But in the same in the same example, if I want to represent from the numbers ranges from 0 to 7, then I need 3 bits. Why I need 3 bits? Because you can represent 0 to 3, only 0 to 3 you can represent using 2 bits. If you want to represent number 4, you need obviously 4 bits. Why? Why you need 3 bits to represent number 4? Because see, you can see the first line. See, where is 4? 4 is nothing but 2 to the power 2. So that means you require 2 to the power 2 also you require, 2 to the power 1 also you require, 2 to the power 0 also you require, isn't it? Based on those 3 positions only, you will be representing the number 4. How you are going to represent the number 4? See, you can see that example. How to represent 0, decimal 0. See, in your left hand side, everything is decimal numbers. In your right hand side, it is binary representation. Okay, how to represent 0 in binary? It is nothing but 0, 0, 0. What is actual meaning? How to represent in polynomial form? It is nothing but 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0. Fine. Ultimately, you are going to get 0, 0, 0. You have to write 0. Now you can ask, why can't I write only 1, 0? The meaning is same, isn't it? But whenever you are dealing with computer system, computer field, if it is 3 bits, then you have to fill that 3 bits. Either it may be 0 or 1, it may be anything. Okay, if you are giving 3 positions, then all the 3 position has to be filled, because each and every bit has got meaning. That is the reason why you can represent 0 in 3 bits as well. Okay, 0 can be represented in 20 bits also, 100 bits also you can represent. Okay, based on the architecture. But as of now, you are trying to represent the number from 0 to 7. That is the reason why you need 3 bits. Now in the same fashion, if you want to represent the number from 0 to 15, how much bits you need? Because up to 7 only you can use 3 bits. If you want to use number 8, then definitely you need 4 bits. That means 4 positions. Okay, I will be having the separate table in the last slide. I will show you, but as of now you concentrate over here. Okay, now how to represent decimal 1 in 3 using 3 bits? You are going to represent a decimal number 1 in binary as 001. How to represent the same number in polynomials? It is nothing but 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. It is nothing but 001. 001 is nothing but 1 or decimal 1. In the same fashion, see, up to 3 I have already explained. Let us explain 4. Why 4 is 100? Can anyone say? Can anyone think of it? the number 4, the decimal number 4 is nothing but 100, because 2 to the power 2 is how much? 4, right? So you are going to put 1. If you have the value 4 there, you are going to put 1. So 1 plus 2 to the power 2 to the 0 into 2 to the power 1 plus 0 into 2 to the power 2, sorry, 2 to the power 0 is completely you are going to get the value 4. In the next example, 5. How to represent 5? To represent 5, how much bit you need? How much ones you need? You need 2 ones. Why? 2 to the power 2 is 4. You have to put 1 over there. You don't need 2 to the power 1, and you need 2 to the power 0. 1 into 2 to the power 0. That is nothing but 4 plus 1. 4 plus 1 is nothing but 101. And 101 means in the decimal number system, it is 5. Okay. Now how to represent 7? Why 7 is 111? Can anyone think? Why decimal number 7 is represented as 111? Because you need 2 to the power 0 also, you need 2 to the power 1 also, you need 2 to the power 2 also. You need those 3 positions. After adding those 3 positions only, you are going to get 7, isn't it? How? Represent that. 2 to the 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Total how much you are going to get? You are going to get 4 plus 2 plus 1. Total 7. You can see this example also. In the first line, you need 3 position means you are going to put, instead of, see, in the third line I have put all zeros, isn't it? You have to replace all zeros with 1. If you want the above number, you have to put 1 over there. If you want to represent 7, you need 4, you need 2, you need 1. After adding these 3 positions, you are going to get the value 7, isn't it? 4 plus 2 plus 1. Concentrate on that right hand side, isn't it? So if you want 4, you have to put 1 below that. If you want 2, you have to put 1 below that. If you want 1, you have to put below 1 that. Okay, then after adding all those values, you are going to get the value 7. That is what I represented over here. Okay, let me give one more example over here. So see, if you want to represent the number 25 in binary, then how to represent 25? See, I have directly represented 11001. How I got 11001? How to represent 25? So to represent 25, what are the numbers you require? Go to first line, that 2 to the 7, 2 to the power 7, 2 to the power 6. Go to first line. And just observe the below line. Below line is nothing but, see, 2 to the power 4 is 16. Can you see? 2 to the power 4 is 16. 2 to the power 3 is 8. So you require those two, isn't it? If you want to get 25, how many numbers you have to add up? You have to add 16. So you have to take 16. You have to add 8. 16 plus 8, how much? 24. Do you need 4 now? If you require, see, if you put 1 below the 4, how much it will happen? 24 plus 4, 28 it will happen. You don't need 28. You need to represent only 25. That is the reason why I have put 0 below the 2 to the power 2. I have put 0 below the 2 to the power 1, but I have put 1 below the 2 to the power 0. Why? I need 1. So why I need 1? See, I already got 24 and I have to add one more number to make it 25, isn't it? So that is the reason why I put 1 below the 2 to the power 0 position. See, this is what I represented. See, can you see the arrow mark? I have represented the position of that ones and zeros. So if you want to take that number, you have to put 1. If you want to exclude, if you don't want that number, you have to put 0. See, I wanted 2 to the power 0, that's why I put 1. I don't want 2 to the power 1, that's why I put 0. I don't want 2 to the power 2 value, that's why I put 0. I want 2 to the power 3 value, that is nothing but 8, I put 1. I need 2 to the power 4 value, that is nothing but 16, that's the reason why I put 1. So after putting those values, I got 24 plus 1. So total 25. If I ask represent 25 in binary, then the value will be like 11001. So if you want to store that particular number 25 in your computer system, then computer will convert your decimal number into binary and it will store that binary value in computer system. The binary value is nothing but 11001. Okay, you can pause the video and you can analyze this particular thing. If you have a little more doubt, I have one more example. See, you can see this example. See how to represent the number 17. What are the numbers you require to represent 17? See, do you need 8? Do you need 4? Do you need 2? Add up. If you need, you can add up. You add up and see. If you exclude 2 to the power 4, see, for example, you may say, sir, I don't need 2 to the power 4. I just want to represent 17 using 2 to the power 3, 2 to the power 2, 2 to the power 1 and 2 to the power 0. Can you represent? Try it. You won't get the number. You can represent those 4 values up to 15 only, isn't it? What is 2 to the power 3? It is 8. If you put 1 below the 2 to the power 3, you are going to get 8. If you put 1 below the 2 to the power 2, you are going to get 4. If you put it 1 below the 2 to the power 1 position, then you are going to get 2. If you add up 8 plus 4 plus 2 plus 1, you are going to get only 15. But you require 17. You want to represent 17. That is the reason why I have gone for 2 to the power 4 also. Understood? So that is the reason why below 2 to the power position or 2 to the power 4 position, I put 1. Now I don't want 2 to the power 3 position. I don't want 2 to the power 2 position. I don't want 2 to the power 1 position. But I need 2 to the power 0 position because I want to get 17. I want to get the number 17. Now I already got 16. I need one more to add to 16. So I need 2 to the power 0 position also. That's why I put 1 below the 2 to the power 0 position. So total, how much I got? 16 plus 1. That is nothing but 17. Okay, in the same fashion, if I want to represent 51, what are the numbers I require? See, can you represent 51 only using those 5 positions? What are the 5 positions? 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. Can you represent using by putting 1 1 1 1 values below those positions? No, you cannot get. You are not going to get. If you want, you can add up. You just take a sheet, pen and paper and try to put all one and try to add all the values, relevant values of that particular power. What are the values you are going to get? You are going to get 16 plus 8 plus 4 plus 2 plus 1. Isn't it? You are not going to get 51 over there. But if you want to get 51 over there, you have to add one more position, that is nothing but 2 to the power 5 as well. Now what I have done there, see, 51 equal to the actual binary number is 110011. Why I have put 1 below 2 to the power 5? Because 2 to the power 5 is 32. I require 32 because 32 is smaller than 51. Isn't it? I need 32. Now, why I put 1 below 2 to the power 4? Because I need 16 as well. What is 32 plus 16? So 48. Total 48 I got. Still 3 more values I have to add to make it 51. So do you require 2 to the power 3? No, I don't require 2 to the power 3. Why? Can anyone say why? What is the value for 2 to the power 3? 2 to the power 3 is nothing but 8. So I already got 48. If I put 1 below the 2 to the power 3, then I will be adding 48 plus 8. How much? 56. I don't need 56. I just want 51. That is the reason why I did not put 1 below the 2 to the power 3 position. I put 0. Do you need 2 to the power 4? If you need 2 to the power 4, how much value you are going to get? What will be the value? You are going to get 52. Why? 48 plus 2 to the power 4 is nothing but 4. Sorry, 2 to the power 2 is nothing but 4. So 48 plus 4 is 52. I don't need 52. I just need 51. So, but that is the reason why 2 to the power 2 position. I just put 0 below to the 2 to the power 2 position. Now I put 1 below 2 to the power 1. Why? I need 2 because 48 plus 2 is 50. Till now 50, I got 50. Now I want one more. So that is the reason why I put 1 below the 2 to the power 0. Understood? So while considering the bits, you have to see what is the maximum number value, and you have to think whether I require that value or not. Based on that only you have to number the position. Okay, you can pause the video and you can analyze this. If you have any doubt, you change the number, you put 1 for all the positions and add up the value. How you are going to get the how you are going to get the value? Just consider this example also. See, you can go to the first line. See, it is like 1 2 4 8 16 32 64 128. So based on your requirement, based on your number, you have to put the position as 1. If you don't want that number, put the position as 0. Only that much, isn't it? You can pause the video and you can analyze this. If you have any doubt, you can put a message in WhatsApp. I will answer your queries. Okay, but you have to practice. You have to take the pen and paper and practice this. Fine. Now let us go to octal number system. Okay, so far you have seen decimal number system as well as binary number system. Now it is octal number system. So the first point is it ranges from 0 to 7, obviously, because base is 8. So 8 is nothing but 0 to 7. What is the meaning? 0 to 7 means you can go from 8 to the power 0 to 8 to the power 7. So these many values you can get. So what is 8 to the power 7? You are going to get a very big number, because 8 into 8 into 8 into, so you have to multiply 8 7 times. So you are going to get a big number. Okay, so the binary bits will be from 30, so like 3 bits, like 30 to 3 ones, isn't it? 000 to 111. Why it is like that? I have already given the example over here, where it is here, isn't it? You need 3-bit values to represent up to 7, isn't it? See, if you want to represent any number up to 7, you need 3 bits or 3 positions. If you want to represent the value up to 15, you need 4 positions, isn't it? Correct? Can you see there? In the same fashion, if you want to represent any big numbers, you may require many bits. That is what see you have done while representing 51, isn't it? 51 is little more little big number. So how many bits you have taken? 1 2 3 4, total 6 bits you have considered here. It is not 2 bits, or it is not 4, it is not 3 positions or 3 bits. You did not take 4 position or 4 bits. You have taken total 6 bits to represent number 51, isn't it? So in octal also, say they have given the third point as binary bits will be from 000 to 111. Okay, see what is 111? See, I have in the brackets I have given 111 is nothing but 4 plus 2 plus 1. How I got 4? 2 to the power 2, isn't it? What is 2? 2 to the power 1. What is 1? 2 to the power 0. So everything is position. You have to think in positional way. Okay, everything is position. You have to consider all the numbers based on that position. Okay, now let us take an example here. See, for decimal number system, how I represented the number in the brackets, I put the number in the brackets in the and I put 10 as a base. But it is an octal number system, so you have to put the base as 8. Okay, now what is 7 to the base 8? How to represent that 17 to the base 8? So it is nothing but 1 into 8 to the power 1 plus 7 into 8 to the power 0. So it will be little more confusing, isn't it? That is the reason why I said you always have to consider the numbers from right hand side. It will be better, because see, 7 into 8 to the power 0 plus 1 into 8 to the power 1, isn't it? It is in a increasing fashion. 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3. Because you do not have decimal values here, that decimal point, you do not have that pointed values, floating point value. That's why we are starting from right hand side. Okay, now what is 8 to the power 1? It is just 8. What is 8 to the power 0? It is 1. So 1 into 8 plus 7 into 1, it is nothing but 15. So 15 is the decimal form. Remember, whenever the octal value will be interpreted as, if you are going to interpret that octal value, ultimately you are going to get the product as decimal, product in decimal form. So 15, that is the reason why I represented 15 in the braces, brackets, and I put 10 as a base. Understood? So you can take one more example. See, octal digit is 2322. Okay, so 2322 inside the brackets, and I put a base as 8. How to convert this? How to interpret this? So you have to, you can see the polynomial form. What is the polynomial form? First number. Okay, let us start from right hand side. It is the better habit. You have to cultivate that habit. Let us start to write from right hand side. Take 2 into 8 to the power 0 plus 2 into 8 to the power 1 plus 3 into 8 to the power 2 plus 2 into 8 to the power 3. So that is nothing but the polynomial form. The same form for decimal, what you have done? If the example was like 2322 to the base 10, what you have to do? It is something like 2 into 10 to the power 0 plus 2 into 10 to the power 1 plus 3 into 10 to the power 2 and plus 2 into 10 to the power 3. That is for decimal number system. But this is octal number system. Octal is nothing but 8. It has got base 8. That is the reason why we have taken 8 to the power 0, 8 to the power 1, 8 to the power 3, 2, 8 to the power 3. Understood? Okay, now again from the right hand side, what is 2 into 1? 2. What is 2 into 8? It is 16. What is 8 to the power 8? 64, isn't it? 3 into 64. That is nothing but 192. What is 8 to the power 3? I am not, I don't know the exact number. It is something like 8 into 8 into 8. You can take, you can take the calculator and you can check. And that 8 into 8 into 8 into 2. Whatever the value into 2. So 1024. That means obviously 8 to the power 3 is 512. Isn't it? 512 into 2 is 1024. Don't you think like that? Isn't it? So 8 to the power 3 is 512. 512. Okay. So ultimately you have to add up all the values. And if you add up all the values, you are going to get the value as 1, 2, 3, 4 to the base 10. So that value is in decimal form. If you want to interpret, if you interpreting, any octal numbers, ultimately the product will be in decimal form. Okay. So how I got that 1234? By adding 1024 plus 192 plus 16 plus 2. Okay, this is the interpretation of octal number system. Okay, now in the same example, if you have decimal point, how to do? Say for example, if the number is like, you can take the above example itself, 17.2. How to represent 17.2? So for 17, you have to start from right hand side itself. Same, you can copy paste 7 into 8 to the power 0 plus 1 into 8 to the power 1. And after decimal point, you have to start from left hand side. You can recall the very same example of your decimal number system. How you have done? Isn't it? It has started from -1, 10 to the power -1. But in this case, it is not 10 to the power -1. Here it is, you are going to start from 8 to the power -1, because it is an octal number system, isn't it? So you have to change the number, base number. That's it. And the rest of the steps or methods are same. Okay, so you can take up some examples and try to solve. If you have any doubt, you can approach me. Okay, next, the last but not the least, it is hexadecimal number system. Okay, you have seen a decimal number system, you have seen binary number system, you have seen octal number system, and you try to solve some examples as well. I have shown some examples. Now the last but not the least, it is hexadecimal number system. What is hexa? Hexa means 16. Okay, hex means 16. So hexadecimal number system is nothing but the radix or base value is 16. So the number will ranges from 0 to 15. Okay, why it is 0 to 15? Total you have to get 16 numbers. So ultimately, if you want to get 16 numbers, it has to range from 0 to 15. Octal will range from 0 to 7. Decimal number system will ranges from 0 to 9. You have to recall all those concepts. Okay, now the binary bits will be from 0000 to 1111. So total 4 positions you require. Now as you have already solved some examples of your binary system, definitely you will be knowing why you need 4 bits or 4 positions. because if you are not using 4 positions, you cannot represent more than like 8. Up to 7 you can represent using 3 bits, but if you want to represent number 9 or number 10, definitely you need 4 bits in a binary system. So that is the reason why we are representing binary bits will be for mainly for hexadecimal numbers. Binary bits will be from 0000 to 1111. So in the brackets I have shown also why it is 1111. So it is like 8 plus 4 plus 2 plus 1. Why? How I got that values 8 plus 4 plus 2 plus 1? Again that position 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Isn't it? Always remember, students, always remember, whenever you are dealing with binary systems, whenever you are dealing with zeros and ones, always remember that position values. 2 to the power 0, 2 to the power 1, 2 to the power 2. You have to by heart that values mainly. For the, so if you want to speed up your, problem solving skills, you have to somewhat up to 2 to the power 7 you can by heart, isn't it? It is a multiples, correct? It is like 1, 2, 4, 8, 16, 32, 64, 128. It's a multiples. Correct? So you have you can imagine those numbers. Based on that numbers only you are representing any number to binary system. Fine. Now you can take the example. See as it is a hexadecimal number, base is 16. Can you observe over there? Can you observe that example? See, let me zoom in a little bit. Yeah. It is nothing but 20 to the base 16. How to represent 20 to the base 16? Again, cultivate the habit of understanding from the right hand side. 0 into 16 to the power 0 plus 2 into 16 to the power 1. What is 2 into 16 to the power 1? It is nothing but 32. What is 0 into 16 to the power 0? It is 0. Why? Any number multiplied with 0 is 0. So ultimately you are going to get the value as 32. Now what is that 32? 32 is nothing but the decimal form of octal number 20. That is, not octal, hexadecimal number of 20. Okay, why it is hexadecimal? Because it has got the base 16. By using the base value only, you have to decide what kind of number it is. Okay, if I have written 8 over there, then it is an octal number. If I have written 16, then it is a hexadecimal number. If I see, for example, 20 to the base 10, if I have written like that, then it is a decimal number. So after interpreting, after solving that 16 to 20 to the base 16, you got 32. So 32, you will get only 32, but always remember it will be in a decimal form. That is the reason why I put brackets and I put 10, just for your understanding purpose. You have to remember, after interpreting, ultimately you are going to get the decimal value. Okay. Now see, you can see one more example over here. 164. How to represent 164? 164 is in hexadecimal form. Why? How can I say 164 is in hexadecimal form? Because I have given the base 16 over there, isn't it? Can you see that example? So I have given the base 16. That's why 164 is in hexadecimal. I want to convert it, or I want to change, I want to interpret that 164 in your computer system. Means you have to follow the same step. Let us start from right hand side. It is nothing but 4 into 16 to the power 0 plus 6 into 10 to the power 16 to the power 1 plus 1 into 16 to the power 2. What is 4 into 16 to the power 0? It is nothing but 4 into 1. Why it is 1? Any number to the power 0 is 1. Okay. 4 plus, what is 6 into 16 to the power 1? It is nothing but 6 into 16. 6 into 16 is 96. Okay. Plus, what is 16 to the power 2? It is 256. So 1 into 256 is 256. Add up all the values. Ultimately, you are going to get the value as 356. So you got 356. That 356 is in decimal form by default. So that is the reason why I put one bracket and I put the base 10. Okay, you can solve the numbers in the same fashion, but if you have the decimal number system, that dotted number, if you have floating point number, then you have to follow the which fashion? See, you have to follow let me see, let me get into here. So the same, this example, instead of going to 10, you can go for 8 or 16. If it is octal number, if you have point value in octal number, you can go for 8. If you have hexadecimal value, you can go for 16. You can see the example here. If the 250 is written from right hand side by considering 10 to the power 0, 10 to the power 1, 10 to the power 2, but after that dot you are considering from left hand side. So same fashion you can try to solve for octal as well as hexadecimal. Understood? Now let me show you the last table. So this is the overall table. You can think this particular example as overall one. So you have different numbers with the different base. Okay, let me zoom in. So this is the table where you have the decimal number ranges from 0 to 15. 0 to 15 in decimal, it is a normal number system. You don't need to worry much for a decimal number system, because whatever the number system you use in day-to-day life, the same number system. You don't need to think much on that decimal number. It is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 10, 11, 12, 13, 14, 15. Okay, but when it comes for binary, I have that the example, the people, those who have given the example, they have taken 4 bits. Why they have taken 4 bits? Can anyone guess? Why they did not take only 3 bits, or why they did not go for 5 bits? Because you are trying to represent a number from 0 to 15. So to represent the number from 0 to 15, you need 4 positions, isn't it? That's why they have taken 4 bits. Okay, 0 is represented 0, 0, 0, 0, and 1, 15 is represented as 1, 1, 1, 1. How 15 is represented as 1, 1, 1, 1? The same example. Which is the example? See, in the brackets, can you see the brackets? 8, see in the 1, 1, 1, 1 in the brackets I have given 15. So in the again I have gone for some brackets. There I have written 8 plus 4 plus 2 plus 1. Ultimately, if you add up all those, you are going to get 15. The same thing they have gone here. They have gone for. Understood? So you can solve. If you have any doubt, you can come to me. I request everyone to solve this. Take number 12. Why it is 1100? Why it is 1100? Because you require 2 to the power 4 as well as you require 2 to the power 3. But you don't require 2 to the power, you require 2 to the power 3 and you require 2 to the power 2, but you don't require 2 to the power 1 and 2 to the power 0. Because 8 plus 4 is 12. Fine. So if you are getting confused with the binary, make sure that if you are getting any binary number, put that position values from right hand side. Start putting the position values and give the values for that position as well. Then you are going to get the actual idea why they have put 1 1 there below that particular position. Okay, now you can concentrate on octal. Octal has base 8. Now up to 7 it is same, no changes. Whatever the decimal number they have taken, same number they have taken for octal also. There is no change. 0 0 0 1 1 2 3 4 5 6 7. Up to 7 it is same. But 8, for 8, see, for decimal 8, what is the octal value? They have given 10. Actually, it is not 10. It is 10. Remember that. It is not 10. It is 10. Why 10? Because they have taken 2 positions. 2 position means, from right hand side, if you say the position value is 8 to the power 0. What is 8 to the power 0? It is 1. Isn't it? And for the second position, I'm talking about the decimal value 8. The value for 8 is 10, isn't it? So in left hand side they put 1. Why? They need 8 to the power 1. That is nothing but 8. Did you understand? So what is the 9? Why it is 1 1? Because 8 plus 1. Isn't it? Put the same value. Now you are not putting the position value as 2 to the power 0, 2 to the power 1. For octal, the position value is 8 to the power 0, 8 to the power 1, 8 to the power 2. Like that you have to imagine. Now, why 9? The decimal number 9 is 1 1 in octal. Just go to decimal number 9, and the same equivalent value for octal is 1 1. Why it is like that? How to write 1 1 in decimal interpretation? Sorry, in octal interpretation? It is 1 into 8 to the power 0 plus 1 into 8 to the power 1. What is 1 into 8 to the power 0? It is 1, plus what is 1 into 8 to the power 1? It is nothing but 8. 8 plus 1 is 9. So you are going to get the decimal value 9. Did you understand? Like that you have to interpret. Why the decimal value 12 is 14 in octal? Can you say? So how much you have to add to get 12? You try to convert, try to interpret. You take 14, try to interpret. How to interpret? You have to interpret like this. 17, I have taken 17, like, right? So you have to put 14 and try to interpret. You are going to get the same value. You have to interpret in the same fashion. Don't get confused. Okay, try to solve. If you get any errors, or if you get any doubt, or if you stuck in somewhere, take the photo and send it to me. I will solve it. Okay, I will help you out. No need to worry. But you can see the examples. You can solve by your own, by your own. If you get any doubt, you can come to me. And in the same fashion for hexadecimal, it is base 16 and from 0 to F. I have already explained why it is 0 to F. After 10, they have gone for alphabet values, A to F. Remember, it is not like after F you are going to put G or H. It is not like that, or Z. You cannot do that. The maximum number in hexadecimal is 0 to 15. Up to F or up to 15, you can go for A to F. Only that much. From 10 to 15 is A to capital. That also in it should be in uppercase. 10 is nothing but A. 15 is nothing but F. Up to 15 you can represent. Okay, now that means from 0 to F is nothing but 0 to 15. It is understood. Now whenever you see the values like A or B or C, it is understood that it is a hexadecimal number. You don't need to confuse. Okay, definitely they usually in questions also they are going to put the base as 16. By that time only you are going to get it. But if they are not giving the base 16, it is understood that if the question has got this like a capital A or B, some numbers with the A, it may be like 8A. It is obviously it is a hexadecimal number. Okay, now in the next video or next class or next session, I will definitely show how to convert, because your application or your system may be supporting hexadecimal or octal number, but ultimately all the data has to be stored in binary system, isn't it? Binary numbers, zeros and ones. Now how to convert your octal number to binary, or how to convert your decimal number to binary, how to convert your hexadecimal number to binary? Ultimately everything has to be in a binary system, isn't it? Then how to convert binary number to a octal number, or how to convert binary number to hexadecimal number? So all those conversions are there. So I will solve and I will put the photo or picture or any video. Let me see what can be done. But you till now, like whatever the things I have explained, you just take a pen and paper, try to solve. If you stuck somewhere, get the photo and you can send it to me. Okay, I will solve and I will let you know what is the answer. Okay, yes, let me wind up here. Thanks for watching.